Here, this is a very high precision simulator for spacecraft dynamics. And we're looking at satellites in geostationary orbit. The purple trace here is an uncontrolled satellite that's placed in geostationary orbit. And you can see that if left alone, it just drifts along the orbit due to various perturbational effects on the satellite, such as solar and lunar gravitational attraction, the fact that Earth isn't a perfect sphere, solar radiation pressure, and things of that nature. So satellites are equipped with thrusters to keep them in the position that you would like them to be in the orbit. So what you see in the red box here is a typical station-keeping window that satellites are placed in. So conventionally, they fire thrusters roughly once every 2 weeks and drift and stay inside of this box. But what we're working on here is to develop advanced control techniques to control satellites with electric propulsion. Electric propulsion is much more efficient in terms of propellant use than conventional chemical thrusters. So they can increase the lifetime of a satellite or reduce the costs of putting a satellite in orbit. And it's simply due to the fact that they are much more efficient with propellant mass. So we can reduce the amount of propellant that we put on the satellite for station-keeping purposes. They also, on the other hand, provide interesting control challenges for us. They produce thrust at much lower levels than chemical thrusters, and so they need to be operated continuously to give you a similar imparted impulse to that of chemical thrusters. So the work that we do here at Merle is to develop advanced control techniques to control satellites with electric propulsion in fuel-efficient and very precise ways. It's math and it's algorithms, and we implement it in software, and we then test it against this commercial software to verify and validate that our techniques are appropriate and work properly. You need to have good knowledge of spacecraft dynamics, orbital dynamics, orientation dynamics of spacecraft, and you need to have good mathematical background in optimization and numerical techniques and control theory. So the electric propulsion is just starting to catch on, and the control of satellites with electric propulsion is a new area, and our use of model predictive control to do that is cutting edge. We're working really hard today on model predictive control algorithms for electric propulsion because this is really the enabling technology for future next generation satellites.